Welcome back to another episode. Now, if you've been paying attention to the past episodes of the show, you've noticed we've been focusing an awful lot on .NET. This is because .NET is not only extremely important, but it's also extremely powerful base platform. We've decided that the rest of the shows from here on out are going to focus so much on .NET that we've even renamed the show to call it the .NET Show. This means that all the rest of the episodes are going to focus on giving you the information you need to develop great .NET applications. For this first episode of the .NET Show, we're going to take and revisit what is .NET. We're going to talk with some individuals that have played a role in developing the .NET story to hopefully give you a better and clearer understanding of .NET is. But before we get to that, let's go check in with Erica and the news.
Welcome to the MSDN News Update. I'm Erica Wickers. The Microsoft Network Solutions Group has released the Web Admin tool to illustrate how you can use Windows 2000 and Active Directory to manage and administer shared web-based services. While targeted at enabling ASPs to lower their operation costs through the use of delegated administration, user self-management, and real-time computer management, this tool provides capabilities that are equally useful to other types of service providers and enterprise customers. In early January, at the 2001 International Consumer Electronics Show, Bill Gates revealed to the world the highly anticipated Xbox video game console during his keynote address. Over 200 game developers are currently creating Xbox games for launch, which is set for fall 2001. Microsoft also demonstrated support for the global video game development community last November when the company announced the Xbox Independent Developer Program and the Xbox Incubator Program. These programs both enable game designers to create prototypes and begin development of Xbox games through the Xbox Prototype Kit and official Xbox Development Kit. Also in January, Microsoft made available a special redistributable version of MSXML 3.0, which will allow developers to easily provide the latest XML parser from Microsoft as part of their software distribution. This package supports the Microsoft Windows installer technology and allows for redistribution on down-level platforms including Windows 98, Windows NT 4.0, Windows 2000, and Windows ME. Recently, MSDN Online launched a new e-business developer center. The e-business developer center will guide architects and developers to understand strategic e-business scenarios and to successfully design and build solutions for these scenarios with the appropriate Microsoft products and technologies. The new developer center can be found at msdn.microsoft.com/ebusiness. Be sure to check out the show transcript for links to more information on these news items. And that's been the MSDN News Update. I'm Erica Wickers.
One of the most important things to understand about .NET is probably what it is to begin with. Now, here to help us understand what .NET is and why it's important to you is Charles Fitzgerald. Welcome, Charles.
Hi.
So, what is .NET?
We really think of .NET as being about services, this new idea of software as a service, and how do people build, deploy, operate, integrate, aggregate, consume this new set of software services that are delivered over the internet.
But how does that differ than what we're doing already today?
Well, it's kind of interesting to go back and look at how we've built software over the last probably 10 or 20 years. And we really have kind of harnessed ourselves to this economic engine of growth known as Moore's Law, where the code we wrote this year, next year was going to run faster, it was going to run more cheaply. And that's been a great phenomenon to really, for Microsoft, other companies to hitch their business to. And it was sort of the moral equivalent of having the wind at your back in terms of the set of investments you made. And we now live in this world where there actually are two very powerful economic engines. Moore's Law still has at least 5 to 10 years left on it. But there's another very powerful economic force, which is the plummeting cost of communications. And obviously we've seen a phenomenal amount of investment go into building out the internet over the last 5 or 6 years. And we really are in a position where we have global connectivity. It's very, very low cost relative to everything that came before us. And the question question we've really started to ask is, how do you start to build really interesting applications in an environment where you have both abundant processing and also abundant communications capabilities? And at the very highest level, a lot of what we're trying to do with .NET is figure out how to build a platform that harnesses both of these economic forces. We want to have the equivalent of the wind at our back and also be running downhill. And that's sort of where we start as we think about how to package software in a .NET environment.
I mean, IAS and ASP and stuff like that, wasn't that something that enabled that same functionality of utilizing the internet for doing stuff on your servers?
If you look at what's happened over the last 5 or 6 years, we've really seen a revolution in the way users talk to applications, in the sense that you can now sit down, type in a URL, click on a link, go visit tens of millions of different websites. Most of them are probably ones you wouldn't want to visit, but nonetheless, it's really revolutionized the way users talk to applications. And we think actually the interesting question now is, given we've got this global connectivity, how do we start to revolutionize the way applications talk to applications, or the way software talks to other software? Because if you look at the internet itself, it's very, very distributed. You actually can go back to the DARPA design roots of the internet, which was about building a network where in the time of some sort of military conflict, you could blow up half the nodes, and the surviving nodes could still talk to each other. So you had this very, very distributed architecture. Yet from an application standpoint, the browser revolution has actually been a pretty significant step back. It's not distributed in the sense that we do all of our processing on the server, and we pretty much use all the power at the edge of the network as a dumb terminal. And that dumb terminal model, where you do all the processing on the server, and periodically you ship out a picture of what happened on the server, and when the user wants to do something, you send everything back to the server, that model really made sense in a world where processing power was scarce. But we now live in this world where there's very, very abundant processing power around the edge of the network. We haven't seen 2000 numbers yet, but for 1999, Intel shipped on the order of 2 trillion MIPS. That's a phenomenal amount of processing power, most of which is sitting out on the edge of the network. So the question we're sort of asking ourselves is, given that the communications fabric of the internet is distributed, how do we start to build applications in a distributed and very internet native fashion? And the endpoint that we've come to is this idea of .NET and starting to build things as web services where you can still have very rich software content, but also take advantage of that near ubiquitous communications capability that we now have in the world.
So then .NET really relies an awful lot on what you're calling web services.
Right.
So what exactly are web services? How does
Well,
.NET expose
there sort
those?
of are probably three tenets that are worth talking about from a .NET perspective. The first of these is just this idea of the evolution to software as a service. And software as a service is sort of two transformations, one at the technology side, the other from a business perspective. And historically, when anybody's built an application, they've built a standalone set of bits. From a release perspective, you sort of throw it over the wall to your customer. You call them again in a couple of years when you've got a new release of those bits. And it's been a very, very discrete release process. But given that we now live in this world where we have ubiquitous communications, it's reasonable to start thinking of an application not as a standalone discrete set of bits, but something that we can actually deliver on a continuous basis. So you get this continuous delivery of value via continuous delivery of bits. So we can start to push updates, we can start to push bug fixes. We're going to leverage all that communications capability. And we should stress that we still absolutely believe in a world of having very rich, very deep software content brought together with this communications capability. And in a lot of ways, the development of web applications over the last 5 years has been a trade-off between the rich functionality of a sophisticated software asset and ease of deployment. You either built a browser-based app or you went and you built a very sophisticated application. And to a large extent, Microsoft created that trade-off. There were a set of things that made it very difficult for people to deploy interesting new applications, do it on a very large scale. A lot of these things come back to the so-called DLL hell. And one of the key tenets for us around .NET and this idea of delivering software as a service is to eliminate that trade-off and make it very easy for you to deliver deep, rich, sophisticated software content and deliver it in a seamless fashion where you can trickle out new capabilities, you can continue to push new bits. And that also starts to change things from a business perspective, where we can move to a model that's much closer to service-oriented delivery, where the customer pays for the service, and they will continue to get updates, bug fixes, new capabilities, and those services can really start to be tailored to what the individual customer is looking for, as opposed to the very discrete releases that we've done historically.
What might be an example of something like that?
Today, as I mentioned earlier, the way we build applications on the web today, it's very focused on how people come and visit your site on an interactive basis. You need to have a user who's involved in actually instigating the interactions. And that makes for a pretty tough business. You've seen this over the last year where the .com business has suddenly ran into some problems from a financial perspective because it was very hard to build the critical mass they needed. And a lot of that was about building themselves into a destination so that people could access their functionality. Think about all the companies that were doing Super Bowl ads a year ago that aren't doing Super Bowl ads. And it was a hard business to build yourself into a brand and a destination to get people to take advantage of your capabilities. Start to think of a model where it's not just users that are consuming your services, but other applications, other services, other developers anywhere in the world can package up their functionality or consume your functionality. So take a company like OpenTable. OpenTable is a .com, they're actually still around, and not only do they interactively allow you to come to their site and make restaurant reservations, but they also have started to expose their site programmatically, which means other sites, other applications can start to embed their restaurant reservation engine directly into their application.
Okay, so OpenTable is a website that allows me to go and browse through a set of restaurants that they're exposing, and I can say I want to reserve a table Saturday night at 7:30
for 4 people or something like whatever it is. And by exposing themselves programmatically, they now have made the integration with any travel site, any city guide, any newspaper that might ever mention a restaurant. They've made that significantly faster, easier, cheaper to do than we could do integration before. There are a lot of people who are trying to bring different applications together over the internet today and spending a lot of time and energy, and you've actually seen a phenomenal amount of sort of creative hacks to make that work. And the real opportunity is to put down a foundation, this foundation we call web services, that gives us an internet native methodology for how different applications, different services, different devices can talk directly to one another. And once you have that methodology in place, not only can you expose your business as a service and get the business benefits of delivering your software as a service, but you can also start to think about, how do I make these different things work together? How do I integrate and aggregate different services? And there's a great parallel here with what happened with component software. Component software was about defining a set of conventions for how do I reuse and program against an arbitrary piece of code. And it really transformed the economics of software development because it allowed people to start to think about what do they want to buy off the shelf, what do they want to build themselves. Nobody has enough development resources. Microsoft, any other company, nobody has enough developers to do everything. And getting to a world where you can start to incorporate arbitrary pieces of functionality off the shelf is very, very powerful. And one of the key tenets of this web services model is that we can aggregate and integrate different services. So you may start to think of your business as a bundle of services, some of which you expose externally for your partners or your suppliers or your customers to consume, some of which you may only expose internally. But by having that set of conventions for how we consume these services, how we reuse these services, how we aggregate these services, we can start to make or buy decisions. And the value you create is not just in the code you write, but you can also start to create value by aggregating and integrating other people's intellectual property. And it really unleashes the creativity of the developer because they can start to grab different pieces. And ultimately what we want to see is that every asset on the internet is actually a programmable resource that can start to be combined and integrated and aggregated in new and interesting ways.
So you end up with like a service or a solution that the whole is bigger than the sum of its parts, right, because you intelligently pick the right parts to pull together.
You think about how today, if you're using a component in your project, you go into your project, you import a component, and it's just like that resource was part of your application. Well, we're going to start to let you do the same thing from a services perspective. And you can go and create value by not just what you build yourself, but by starting to stitch other things together. And it really represents a fundamental shift in what people think of as a solution. Historically, a solution has been a single application, a single device, a single node. And increasingly, we're starting to think of solutions as a constellation of multiple apps, multiple devices, multiple services that are marching together with some common purpose in the same direction. And in this world where we have very ubiquitous communications, being able to stitch all those internet-connected things together unleashes a lot of opportunity.
So would it be safe to say then that .NET provides a platform that makes it easy to expose functionality as a easy-to-call API or service? And that in turn allows the developer of the solution or the website to break their service down, break their solution down into the key components, and both use those internally across their entire website, as well as pick specific components and expose those to someone else.
Yep, that's pretty close. The .NET platform is about helping people through software technologies build web services, deploy them, operate them, aggregate and integrate them, and also consume them. And that allows people to think about both exposing their capabilities in a standard way that other people can consume and embed those things into their environment, but also making it easy for the developer to consume other web services and leverage other intellectual property that's out there in the world.
And this is more than just taking and sticking a frame-based site in one of the frames. You're pointing to FedEx
Right.
to be able to get the numbers from them. You're
Rather
actually
than,
calling through.
One of the challenges with HTML is it doesn't really give you information. It gives you a picture of the information. And you've seen screen scraping is back with a vengeance on the web today. And we want to go beyond content aggregation, beyond screen scraping, and allow people to start to programmatically build applications that stitch these different things together. Today, you can build things on top of screen scraping, but it turns out to be very, very brittle. I mean, imagine an application where you want to stitch together your different personal information from a financial perspective. So your bank has a website with some of your information, your broker, your 401k, whatever it may be. I could build an application today that goes out and screen scrapes those different sites and pulls my information together and allows me to look at my complete financial situation. The problem with that solution is it's very, very brittle, because one day I'm grabbing my account balance out of my bank's website. The next day, after they get bought or they change their logo or they redesign their web page and everything moves on the page, I may find myself actually grabbing my account number. So briefly, I may think I'm doing really well financially, but it makes for a very brittle mechanism on top of which to build these interactions between different systems. And we want to have something that gives us a real solid programmatic infrastructure to build on top of. And that's where this web services infrastructure that leverages the internet as the communications fabric, leverages XML as the data format, leverages SOAP as the way to package up interactions between different applications and different services. It gives us a very robust but still very simple framework to build these applications on top of. And from a .NET perspective, we're building a whole bunch of software infrastructure and tools that's totally geared towards that particular methodology. So we want to make it very easy, very intrinsic to build that class of applications. So literally with just a couple lines of code, you can expose your application, your service programmatically so that other people can start to consume that. They can start to integrate that into whatever the application constellation is that they're building.
Thus turning the entire internet into one big computer program.
Well, it doesn't have to be one big computer program, but think of, whereas today you have tens of millions of websites that are out there, they're all effectively islands. I mean, you can go visit them from a user perspective, but if you want any two of those websites to talk to each other, it's very difficult to do. And what the web services is all about is giving us a standard integration methodology so that we can start to treat all of those things out there as building blocks. Now, the people who own those websites, who own those services, are going to decide who has access to them. In some cases, they're going to charge for that access on a subscription basis, on a transaction basis. But we at least have the programming methodology to start to stitch those different things together and make all that stuff work together. I mean, in a world where communications is ubiquitous, we still haven't taken it up to the next level where those different applications, different services, different devices can talk directly to one another.
Now, talking about having things all work together, since the internet is this big mass of different computers out there, we're not talking about just having .NET systems out there or Microsoft-based technologies out there, but there's going to be Unix systems and Macintoshes and stuff like that. How does .NET flow into that world?
Well, the methodology for web services is very intentionally independent of any operating system, any object model, any programming language, any application. It's a set of protocols and formats like SOAP, like XML, that allow us to pull any device, any service, any application, any operating system, any programming model into that world. Because ultimately the thing we want to do is build these constellations of solutions that stitch together new applications, old applications, things from one company, things from another company, and it is a heterogeneous world out there in that respect. And the goal, the real design point for web services has been to create that in a way that is very, very internet native and can get very, very broad reach. And we think we've achieved that with that web services stack.
So it's based upon all the standards that's coming out of the W3C and other sources, so that .NET is just the most standard, the standardist collection of things?
The way I would describe it, the foundation for these interactions, this integration methodology around web services is open, it's accessible to anybody, anybody can implement that on any platform. The decision we've made from a .NET perspective is to target that in a very big way and very, very natively. So one analogy is to think of web services as sort of the railroad gauge for how applications talk to each other over the internet. And with all the .NET infrastructure we've built, we've really optimized it for that particular gauge. You'll see existing systems where people are going to take a car and try and adapt it to run on that particular gauge. You'll probably see other new technologies that are targeted on that gauge. And we still have to do a lot of work to go reach into existing applications, existing data, to make sure that we can get those things onto this XML backbone. Microsoft, for example, has invested a lot of time and energy in essentially providing on-ramps and off-ramps into legacy data systems, even as far back as the IBM mainframe, because it turns out there's an awful lot of data in the world that doesn't support XML today. So we need a way to get that out of those systems and get that into this XML-based web services world.
So if anybody in the audience is currently dealing with some of those legacy-based systems like that, are we saying that they basically don't have anything to do right now, or is there stuff they need to be focusing on as well?
If you've got existing applications, and this is true no matter how legacy it is, there are a couple things that you need to think about. Number one is, what's the data that you care about, and how are you going to express that in XML? So conceptually, people want to think about creating XML schema for all of their different applications. And how are they going to be able to take that application and have it communicate with other applications in this XML world? So that's one place where people can get started. You also can start to think about wrapping a set of SOAP interfaces around those applications so that we can natively call those existing systems as web services. And you can start working on that today. We actually provide a toolkit that works with Visual Studio 6. So you can do that with existing Windows and COM applications, and there actually are other solutions in the marketplace that help people SOAP enable other forms of existing application.
So then what do you think are some of the key reasons that people really should be starting today to start thinking about .NET and getting their applications and solutions ready for it?
Well, it's really a question of what kind of opportunity do you want to pursue with your code. To the degree that your code can be consumed by more endpoints, that it's easier for customers to embed or take advantage of that functionality in their environment, that's a huge opportunity. At the same time, you may be interested in leveraging other capabilities off the shelf. You know, do you want to build your own authentication system, or do you want to leverage one off the shelf? The same kind of decisions that people have made around components, you can start to, by supporting web services in your application, you can start to have that kind of economic flexibility in terms of how you build your own applications as well.
Do you see .NET as maybe changing the way that we purchase applications in the future? We no longer go down to CompUSA or Egghead or something like that and buy a box and install it?
I think you'll continue to see licensed software for a long time. And I think you'll actually even see people selling services through retail outlets. But there also will be the opportunity for this new delivery model where you do get your bits delivered directly to you over the internet. You might move from the one big licensing fee to a much more discrete monthly subscription type pricing. And you'll see both for a long time, and I think there'll be a lot of experimentation and fine-tuning with business models in terms of what works, what customers are most interested in, and we're already seeing a lot of that experimentation around web services today.
So maybe this is opening up a new business model for internet-based websites to think about, how do we take and get money back from our users out there because we're providing them a service. We can't be doing this for free all the time.
You bet. I mean, particularly if from an interactive standpoint, a lot of the business models are make it up on volume or advertising based, and you can see people providing or charging for programmatic access to the same system. I mean, in theory, if your customer is consuming your intellectual property in a programmatic fashion, they're getting more value out of it. They're actually embedding that directly into their environment. And if you're smart, you're going to get paid for that and capture some of that additional value that the customer's deriving from it.
Mm-hmm. Well, in closing, do you have any last words you want to take and relay to the audience to help them really understand the importance of .NET and why they should be thinking about it?
There's actually probably one more point that we haven't talked about, and that is sort of the changing nature of the systems we build. So whether it's PCs, whether it's a new class of devices, we think increasingly what we have thought about as standalone nodes are going to become smart, service-aware systems. So not only are you going to have an application or an operating system, but those things are going to be smart about how they consume the services. So as we think about the set of technologies around .NET, one of the key attributes is making sure that they're really smart about how they consume services.
Not quite sure what you mean by that.
So think of MSN Explorer as a great example, where MSN started as a set of services that were delivered via the browser. And we've built a very smart, sophisticated piece of code that has a lot of intimate knowledge about the services that are behind that. Makes it easier to consume those things, makes those things more accessible to the customer, makes them more valuable to the customer. And more you're going to start to think of the devices and the PCs that we work with every day, not only as having a set of capabilities that run locally, but they're also going to have a lot of knowledge about the set of services that you're going to consume that resides out there on the network. And it sort of comes back to that point I made at the beginning, that there's a phenomenal amount of processing power around the edge of the network. And as we start to move into this world, more and more people are going to leverage that processing power to build systems that are smart about how they consume and how they deliver services to the customer, and use that to deliver more and more capabilities.
And so these devices like the MSN Explorer, you're saying the fact it knows you're doing email and it's know you're looking at news, and it can access those services directly. It's not just redirecting you to a website, but it's actually interrogating.
If you look at a lot of the really successful phenomena of the internet over the last couple of years, they've actually gone beyond the browser. Whether it's instant messaging, whether it's everything in the digital media space, both MP3s as well as streaming media. If you look at everything that's happened around Napster and the whole peer-to-peer craze, it's really been predicated not just on having some HTML in a browser, but it's actually been predicated on having local code, smart code that resides on the edge of the network, and is smart about the set of services that it enables. And more we think that's a direction where you're going to see people make their investments. And it's really not a surprise. I mean, how are you going to compete? How are you going to differentiate yourself over the next couple of years? Well, you're going to go write a bunch of code, and if you're delivering a service, one of the ways you make your service more compelling is to write some code on the client that makes that service more interesting and has a lot of knowledge about the specific capabilities of that service.
So then, would it be safe to say then that where Windows was an operating system that made it easier for the user and the developers to interact with the graphics and processing powers of the local client machine, .NET is something that is exposing the internet and the distributed capabilities of the internet to the customers and to the developers to make greater applications?
Think of just as Windows was sort of about GUI and local presentation, think of .NET as being about services and how we consume those things. And as a result, Windows and .NET are actually very complementary. You'll see a bunch of .NET technologies show up inside Windows as an operating system. From a client perspective, Windows will be a great socket for people who are plugging services into it. And on the server side, Windows will add some of these .NET technologies to make it an even better place to build and deploy and operate the different services that you're running.
Well, thanks, Charles. I appreciate the time you spent with us. I hope you answered some of the questions that our audience has about what .NET is and how soon and why they need to take and jump on that bandwagon. I'm sure I'll have you back here again sometime in the future.
Great. I hope that worked too. Thank you very much.
Well, hopefully that answered some of the questions you have about what .NET is. Now, this is dealing primarily with the overview and understanding of the product and the platform itself. Following a short break, we'll take and talk about some of the developer aspects of .NET and what it means to think through developing a .NET application and set of services. So stay tuned.
Here we are again on our quest for Bill Gates in our attempt to present Bill with an MSDN propeller hat, a gold-plated propeller hat in honor of his status as the chief propeller head of Microsoft. And we've got this golf course that we're heading for. I saw in the paper a couple weeks ago that Bill played golf with Bill Clinton, of all people. This place ought to be around here somewhere. I think we've got, what, 152nd Elwood Drive North? I think that might be it. Well, wait a minute. Is that it? Well, here I am. Got the right address, but zones. What in the world kind of golf course is this anyway? Where's the putting green? Where's the tee off? Where's the pink flamingos? Hey, how you doing? You must be Sean, right? Hi, I'm Andy Hines from the Developer Network at Microsoft, and I'm looking for Bill today. I need to deliver this gold-plated propeller hat to him to kind of symbolize that he's the head propeller head at Microsoft. Somebody told me he might be by here this afternoon.
He usually comes in. He's not here today, though. Sorry.
Oh, so I missed him. Too bad. Well, what kind of golfer is he, anyway?
He's a real aggressive golfer. He goes straight at the hole, doesn't mess around.
No fancy stuff, just right into the hole, huh?
Yep.
And does he have a favorite golf hole?
Yeah, it's right up here. Let me show you. It's the Kingdom. It's a favorite amongst most people, but Bill's got problems with this one. Right next door at hole 7, we got Space Needle, known for its height. But Bill's got his problem down here. He keeps shanking it right off the side. But this hole, this is Bill's favorite hole. We can't figure it out why.
Bill's favorite, I wonder why in the world it is. Maybe you could show me something about how you play this corner here.
Well, Bill usually banks it off right about here, and it ends up hitting the side and
I gotcha.
Going bad.
Okay.
Your best bet, hit it right about there.
Right there, that's
it'll
the
go
one.
straight through and right in the cup.
And I guess you got to watch that little gate under there,
Yeah.
don't you? Okay, here we go. Let's see. Not bad for a first-timer. Well, the day's been a total bust so far. We couldn't find Bill at the office, couldn't find Bill at the golf course, couldn't find Bill at the barber shop. In a situation like this, there's only one thing left to do.
With .NET being so important, and with utilizing .NET being important to expose your services on the internet, obviously as a programmer, it's important for you to understand what it means to provide your services and what you need to do within your applications. Now, SOAP actually provides a very important aspect of how to expose the functionality of your applications on the internet. Now, in the previous episode, we had an entire show talked about SOAP. But to deal about some of the .NET capabilities, I'm going to bring over a guy from the SOAP team to help discuss a little bit further about what .NET means and how SOAP interacts with .NET and allows you as a programmer to expose your interfaces. So joining me now is Henrik Nielsen. You're from the SOAP team. Now, what exactly do you do there?
I am on the standard side, I'm editing the SOAP spec effectively and helping sure that it moves forward in the W3C standards world, and that we build a SOAP infrastructure around SOAP that deals with all the features that we would like to be able to share and use throughout the web.
And why is SOAP so important to what the .NET platform is providing?
The reason why it's so important is that that's the language that any .NET node speaks to any other node on the web. Any other application, the language for exchanging messages is SOAP.
So a .NET node is going to be throwing out some SOAP protocols out there, and another node, whether it's .NET or not, as long as it understands how to deal with a SOAP package, can take and deal with what the .NET platform is providing it.
Well, there's a difference between understanding all of it and understanding parts of it. And one of the things you can do in SOAP is that you could say, well, these are the parts of a SOAP message that you really have to understand in order for us to communicate. And these are the things that would be nice if you can use together, but it would also be okay if we ignore things. So we have a way for saying gradually you can understand these parts, you must understand these parts of it, but these are really optional and we can sort of build on there. And that allows us to move forward in a flexible manner so that new smart applications can speak to older and less smart applications in a graceful way, and old applications know when they're not smart enough and can do that in a graceful way.
Well, that kind of reminds me of just, web pages themselves, the way the HTML language is structured. If a browser doesn't understand a bold tag, it knows how to ignore the thing it doesn't understand, and the information still comes through. But the web page is not providing any information of saying, okay, if this text is not bolded, I totally lose my functionality, and so the browser can't know when it's important and when it's not important.
Exactly. And a classic example of that is that, say I have a copyright statement that I want to embed in my HTML. Any application can come along and say, well, I don't understand this, so I'm just going to skip it, which would probably not be the intent that you would like to have. You would like to be able to say, well, if you don't understand this blob in the message, don't try and understand any of it, fail in a graceful manner. That's a fundamental way of extending things that we have learned from the way that HTML and HTTP have been extended so far in the web, which is exactly ignore what you don't know. And it is an extremely powerful way for extending things and make things work in a backwards compatible way. But at some point, you also need the capability of being able to break backwards compatibility. Don't try and deal with this if you don't understand this copyright statement. I think the analogy to HTML and to the web, if we should talk just to recap what web services are really all about, is actually very useful. What often happens is that when I want to browse the web, I go to my web browser, I find a URL. One of the things that I need to know is which is the address that I should go to. The next thing that I want to do is to be able to say, well, once I get the information from the site, I need to be able to decipher some of the information that comes back to me, figure out I should fill out my name there, I should do this there, I should do that there. And the third part of it is to send the message back and forth. Tying that back to where SOAP fits in. SOAP fits into sending the message back and forth. It doesn't deal with the two other aspects of which they're also support in the .NET framework, but they are dealt with in two different ways. One is the WSDL, which describes...
What does that stand for?
Web Service Description Language. What it does is that it, true to its title, describes services. For example, when you want to talk to a service, it talks about, well, these are the parameters that you have to send along, this is how I work, this is how you can communicate with me, and expose that. The other part of it is the discovery mechanism, and there are a couple of ways you can do discovery mechanism. Just as well as when you use the web for browsing around, there are many different ways that you can learn about URL. Somebody can write it on a napkin at reception, somebody can write it on an airplane you see flying by in the morning, and you might just know by magic that this is the URL that you should go to. Likewise, there are a variety of different ways. There are at least two different approaches for doing this. One is the search engine equivalent of web services, which is UDDI. And the second thing is a simple discovery spec called Disco that contains very little information, but basically is a link. So once I get the Disco blob, which is a XML structure, it says, and over here you can find some information about how to talk about this service in particular.
So here we are back in the year 2000, and Disco's back again, right?
Yes, yes, very much so. Very much. And it's very distribute it and decentralize it everywhere, and you can just stick it in small bits and pieces like you want to.
Okay, so you're saying that that SOAP itself provides a structure. WSDL provides a way of describing that structure, and through UDDI and Disco, you have the capability of discovering the services and the structure to get to it.
Yeah, very much so.
And so this rolls in with .NET exactly how then?
It rolls in actually very nicely in that it is supported. It's very simple to write. WSDL is being generated on your behalf typically when you use .NET. UDDI has its own mechanism for making services available, but .NET rather seamlessly also supports Disco as a mechanism for both discovering and advertising your services in a decentralized manner. So the Disco part of it, the WSDL, and the SOAP mechanisms are integral parts of the .NET when you use it. And UDDI is a search engine that works in a separate way.
So then, let's say you're an application developer, and you're wanting to take and expose some part of your website as a service. What exactly do you need to do in order to take full advantage all the way up to UDDI to get to that sort of capability?
Well, I think the first thing that has to be taken into account is what is it that I actually want to do with my service? What is it, the core piece of my service that I want to expose? And if I just go back to what is it actually that SOAP gives you when you really want to expose things, because at the end of the day, it would have to go into a SOAP message. And the funny thing is that SOAP really doesn't give you a lot. There's no security, there's no payment mechanisms or authentication mechanisms or copyright statements or privacy or talking, any of these services that a lot of people need, so everybody needs. We know these we need these in order to be able to build an infrastructure. SOAP doesn't provide these, and one might ask why is that the case? The reason is really that we could have worked on SOAP for years and years and years to provide a full set of features, but what we have learned by seeing how the web has been evolved over the last 10 years is that regardless of how quickly we work, we will never be able to come up with a set of features that cover all bases. There will always be things that we would not be able to come up with a standardized way of communicating. So SOAP goes the other way around and say, well, let's start from what we can get away with from the beginning and think about how could we provide a framework for extending these services dynamically, because we know we have to be able to do that regardless. It comes back to the way of saying you must deal with this, you may deal with that. There's other very important aspect of SOAP that ties into, well, how should I expose my web services? And that's the whole aspect of composability. A very important piece of the SOAP design and architecture, and in fact also of web services, it's integral part to the whole aspect of web services, is that you can compose web services. You can build services on top of other services, and you can compose them to provide added services. That would
So by that you're meaning exactly what you think
for example,
composing them?
I provide a service that exposes, say, a shoe selling service. I would like to have some way for dealing with gathering information from the people that come and visit my website. It's not something that I do as a part of my core service.
You're a shoe salesman.
Yes, I'm a shoe salesman. I'm not part of gathering information that, for example, can tailor to figure out what type of shoes and what profile and so on and so forth. It could also be a privacy statement. It could be a mechanism for talking about, for example, other links that also provide shoe services. I don't really do that as my core business. I would like to take advantage of other services that actually does that. In order to do that, I have to expose my own web service, but not only expose my own web service, but as part of that service saying, well, there's in fact also different services that are composed together. So when you get a description, a WSDL file, it would actually say, well, here's the part of the services that are broken down. It will talk some about my core piece of the shoe sailing service. It will talk some about the information that will tailor information to specific needs. And you could also have a third part that could talk about privacy and so on and so forth. And you can build these services together. Now, in order to make that work, there's a couple of things that become necessary. One is that there's a mechanism for using these services. In order to reuse services, just as well as for component software and other things, they have to be as flat as possible. Flat thinking in they do one specific thing very well. It could be authentication. They're very good at doing authentication, but they don't do privacy, they don't do payment, they don't do anything else. So breaking down your service in specific modules and thinking, well, this does this specific thing, and this part of my service does this specific thing, and then compose them based on that, makes it much more likely that other services you will be able to use those other services from other parts. There will, of course, also be services that are extremely vertical in that they will cover everything from security, payment, and whatever else, and put them all together. But the reusability of those is probably not as high as if you have flat services.
So you're saying, like, if you're an application developer, you really need to think about your core competencies, and breaking down the services you're providing into the discrete components that make up the big picture, and then exposing each one of those separately across the net. Now, when you're talking about SOAP and how important SOAP is to that, and I'm a .NET programmer and I'm developing a service like this, how much do I need to understand about SOAP in order to write my service?
You don't need to know a lot of the angle bracket level stuff. How do I actually put a SOAP message? .NET provides a great set of services for writing those kind of things for you. That's what it's good at. What some of the things that you still have to take into account is, well, how do I deal with security, which is a more abstract notion? How do I deal with state management? Do I have objects that are exposed in some way, or do I expose them as purely as a stateless, loosely coupled model? And there you have, as a programmer, because those are more abstract notions, you have the choice of going either directions, in a set of directions. And in order to take what I would say full advantage of this decentralized, loosely coupled model, you have to think about, well, what is my security model in that particular environment? How do I maybe sign messages? How do I authenticate them? How do I deal with reliability? How do I deal with a whole bunch of other things? And break down your architecture to be able to deal with those in a more pluggable and modular manner.
Now, to a certain extent, I mean, that was the same thing if I designing a service that wasn't even going to be used on that at all, but just used within my own computer system or application, whatever. The API I expose through my DLL isn't going to deal with any of that junk anyway. I mean, I release an API, and if I want to take and manage the authorization coming through, or licensing, or cryptography, or whatever else like that, I've already got to design all that into my application. I've got to think about all the sort of issues. But when I'm exposing my API, I also don't have to think about the call stack. I don't need to understand, okay, here's how parameters are being stuck on the stack, here's how they're released across to other servers might want to access it. And so you're saying that SOAP kind of is the call stack of the API. It's defining how this is exposed out to people, but it's not exposing any of the actual robust functionality that an application developers need to think about.
Yeah, SOAP is really at the core a message that crosses the wire. And we heard about sort of the need for having more chunkiness data that you want to wrap it, but it's a wrapper that you send along with the wire. How it is being implemented once it gets there is not part of what goes on in the SOAP mechanism. So what you can say, well, I don't deal with authentication, I don't deal with security in that manner. The difference is that not only may I not deal with it, but it would also have to be dealt with across the network in ways that is independent of whatever platform that I actually have on the other end, because it's not exposed to me at the other end what environment that I'm talking to.
Because both ends, as long as they're talking SOAP, it doesn't really matter who's on the other end.
It doesn't.
It's a black box
Yes.
as far as you're concerned.
Yes. And that's a very important piece to have in mind when you design for things, saying don't take into account or don't take for granted that you can use sort of the back channel. Of course I know that this other guy is using this particular feature because we have been talking about it. The best way of writing services that I would say that would be able to withstand a lot of changes is that you take as little into context as a few assumptions as possible about the other end and focus on what are the parameters that I want to expose. How can I do that in a way that is stateless and can be shared, and I have control over what it is I'm doing without requiring some assumptions about the other end.
I mean, a good example would be like, you can't assume the other guy's running Windows, and so you don't want to take and pass an H-wind across the other side, because H-wind may not mean anything to that computer on the other side.
Exactly.
But now, like on a stateless computer model, I mean, that's just dealing kind of with a distributed application on the internet, in that he's not in your memory space.
Yes.
He's not an application that's even necessarily guaranteed to be connected and respondable to your calls, or you to their calls, whatever. And so just thinking through just from solving the problem of designing the application is, keep it stateless, forget any assumptions you might have with the other guy, just package everything up into one return value, pass that back, and let the winds take care.
Yes, very much so. And there's a couple of interesting issues. None of them are new. We know them from the web when we browse around. Servers go down, networks go down, things change, and they change in ways that we often do not really have control over, because I use a web service that you expose. I don't necessarily have control over whether you should change it this direction or that direction. So there comes some responsibility when you write web services, is that if you want them to be reused, you make them as stable as possible, and you make them persistent, and you make them available 24/7, and make sure that people can use them and trust them and for what they want to do. Not trust in I can use them without necessarily trust you as a service, but be able to build applications that use them and reuse them. Just as well as exactly the same thing, if I have a website and I change all my documents every day, search engines and everybody else will get confused, because whenever they go to my site, they will, with something that they knew existed the day before, they will get pages not found. Web services is not different. In order to make this work, you have to be able to have some social agreement on, and some social understanding of what does it mean to expose web services on the web, and to make sure that other people can use them and can build on them.
So then to get back kind of with the original question that I was asking about, you're a developer, and you want to take and write a service and expose it on the net. You're saying on one hand you just kind of think about the programmability of designing a net-enabled service, and thinking about security, thinking about authentication, thinking about statelessness, and that's just the way you're thinking about it. So let's say I wrote an application, and I now want to take and make it available to someone else on the internet that wants to read it. Now, using VisualStudio.net and C# or VB.net or something like that, I can just mark my API as saying it's a web method. Now, that's, correct me if I'm wrong here, but that's creating the SOAP wrapper for that API?
Well, what it does is that it creates a bunch of things. It creates a little piece of discovery markup that you can that you can go get. When you go get it, it comes back and say, at this location you can find a description of what the service is. You can go get the service. The service will then describe, this is how you can make messages and put them together and send them. These are the parameters that you should use, and so on and so forth.
That's WSDL.
That's WSDL. And then you sort of hit the submit button and send the message. And that's how you expose things. And you can then, within that, framework, you have enough to really say, if you want to send that to somebody else saying, I have a service over here, come try it out. And then you can start from there. So that's a very decentralized way of dealing with it. You really do not have any central registration. You can sort of do this completely without anything.
So then, but simply by marking my API as being a web method, I've taken care of the SOAP piece, I've taken care of the WSDL piece, and I've taken care of the Disco piece. Now, then, of the four things you were talking about, the one thing remaining then is the UDDI.
Yes.
And UDDI is what would allow some generic person on the internet to find my service without me telling them about them,
Yes.
correct?
Yes, but that involves a registration mechanism that is specific to UDDI, because there you have some social agreement on that, what it means to expose a service and how it works and those kind of things, and then you register that, and it becomes part of the repository that UDDI exposes.
So that'd be similar, like going to Alta Vista and taking my website address and registering it with Alta Vista, although I guess there is really no formal process there, and if one site registers themselves with Alta Vista, it could be gone the next day anyway. But but UDDI is a more formalized process for doing that. Now, let's say I didn't want to quite go as far as UDDI, and let's say I had a function that calculated the square root, and I wanted to let you know about it, or you wanted to use it, and you told me you wanted to use it. All I'd have to do is tell you the URL of my site, and you could access it then?
Yes.
So UDDI wouldn't necessarily need to happen in that case.
Those are two different ways of dealing with it. Just as well as it maps to how the world works today. Sometimes you go to a search engine, if you don't know exactly what it is that you're looking for, it comes back with a set of results, and you can go there, there, and there. Or sometimes you learn it from other places. And web services is no different. I might know that I just should go to there and it might pick up. And also because it can work in a decentralized manner. I can get somebody else can talk about, well, over there's something interesting. And then you can build just as well as you have a web of hypertext links, you can have a web of descriptions. It's very much the same mechanism. So I can say, well, if I go there, then I get a little bit more information. I can build my understanding of the web services based on a decentralized mechanism, just as well as web pages work today.
Okay, so it sounds like it's very simple then to expose a .NET service on the internet just by marking it as a web method. You don't even need to go as far as UDDI, although that's obviously the preferred way of doing it because it makes it more discoverable. And if you're trying to sell your service, obviously you want more people to know about it, the better. So then let's get back to web services themselves, since that is such a key aspect of what .NET is and the functionality that I as a developer can make use of. What sort of web services are available today?
That's a good question. There's a variety of web services that are being created as we speak. One of the things, to go back to the beginning where we talked about SOAP being very basic, is that we, in the beginning phase of getting started, we will see a lot of very dedicated web services that will be exposed already, and people do that quite successfully, that they take existing applications that they have and wrap SOAP around it, which is a very good way of getting bootstrapped. We also, in the process of starting up as we go along, initiatives for creating, well, what does it mean to talk about reliability? What does it mean to talk about security? And start writing these specs down and push them forward, just as well as has happened with SOAP itself. So we get we go from SOAP, the protocol, to SOAP, the infrastructure, where we have a set of tools everybody can start using. But these things will go on in parallel, and they will go on in parallel forever, because we will never get a full set of services that everybody will be happy with. And we will also have web services that are getting built that will be both dedicated and also generic in the way that they provide services. They can either be horizontal or flat.
Okay, so
vertical.
What I'm reading there, what you said then, in kind of a long description, is basically that it's chicken and egg situation, in that we're still right on the entry level of the .NET services, and so at the current time, we don't have a gigantic dictionary of .NET services you can make use of, and we're actually working very closely with other companies to try to identify what the key services that are needed are, and we'll be exposing those in the future.
Yeah, very much so.
So anybody in the audience that is thinking about a .NET service they might want to have, they should start developing that now, because right now it's wide open playing field.
Yeah,
And if
yes,
you're the
very
first one out there with a system for doing credit card transactions or medical record lookups or GIF to JPEG conversion routines or stuff like that, you can take and expose on a new DDI and get immediate access.
And then as time goes on, there will be more and more services that people will just expect to be there. Just as well as we in HTML, we expect tables to be there, we expect image handling to be there, we expect a various other kind of set of features. And in HTTP, the same way we expect cookies to be there, and we expect caching to be there, and varieties of other things. And these services will then become an integral part of what it is that we're doing. But the nice thing about the SOAP architecture is that we're not necessarily stuck with them forever. We don't just have to pile on, because we have a mechanism for saying, well, this was all good that you could do this with the old style, but now I really want you to use this new style and to do this break in a graceful manner. We didn't have that mechanism for doing that before. We have this mechanism, and hopefully it will sustain the test of time.
Okay.
But that time will tell.
Yeah. So let's say you were talking to a developer out there who hadn't done anything with .NET yet, and there's probably people in our audience right now in that case that they haven't done anything with .NET yet. What would you say to them really clearly as being the key things they need to know, or the key resources they need to utilize in order to develop a .NET application today?
I think the most important thing is to, one, get your feet wet, start playing with it, start looking at what does it mean to expose services.
And that means downloading a Visual Studio.NET.
Yes, and start playing with it, and then look at the application that you have. You typically have applications already that do things. What are the features of those? What are the modules? And start modularize them and say, well, how can we expose those as modular parts of a web service, so that we don't necessarily have to expose it as one big thing, but can break things down. And just as well as there's been modular ways of building software architecture for a long time, these can now be mapped to, we can do modular things on the wire also, and there should be a reasonably well mapping in order to do that. That's what I think, and then otherwise just start rolling.
So it's really not that hard to do. Just think through the problems, download Visual Studio.NET, and stick web method on all the APIs you want to take and expose in the right fashion.
That's certainly the intent.
Okay. Well, thanks, Henrik. I appreciate the time we had talking about this, and I'm sure you answered some questions a lot of our developers might have, and just try to really understand what it means to develop a .NET application. So hopefully that answered some of the questions you have about developing a .NET application. Now, I realize in this particular segment we didn't dive into some of the nitty-gritty code like we normally do, and that's because .NET is kind of more of a high-level concept and doesn't really allow itself to dive into specific technology capability. We'll take and deal with some specific aspects of writing .NET code in future episodes of the .NET Show, so be sure to stay tuned for those episodes. Now, we're still not quite done yet, so stay tuned for the rest of the show.
Welcome to another Somebody at Microsoft.com interview. With me today is Lynn Bohl. She is Marketing Coordinator for SmartCard. Lynn, welcome.
Hi.
Thanks for joining me today.
Thanks for inviting me.
So tell me a little bit about what is SmartCard and what you do for the group.
I'm the Marketing Coordinator for the SmartCard team, and we are doing 1.5 beta, and we've just recently finished a pilot with certain people at Microsoft.
So tell me a little bit about people out there that might not be familiar with SmartCard, what that technology is about.
SmartCard is an operating system on a card that allows you to have all your personal information and or banking information on a card. A little chip that goes in a little credit card. Mm-hmm. Right now we have them on some of our card keys here at work, where we can just put it into a SmartCard reader and it automatically opens up your computer.
Tell me a little bit about what's an average day for you as a marketing coordinator for SmartCard.
Right now we're starting the beta on 1.5, and most of the people on the beta are international customers, so it involves getting all their contacts, their information, who's going to be developing for these SmartCard applications.
So how long have you been at Microsoft?
I've been at Microsoft, it was 14 permanent years in December, and I actually started 9 months before that as what they used to call Microsoft temp.
Mm-hmm. 14 years, that's amazing.
That's a long time.
What was your very first job at Microsoft?
My very first job was on the switchboard. There were 5 of us at that time, 1,100 employees, and the phones were busy all the time.
I bet. Do you remember what's one example of one of the strangest calls you remember?
Interesting calls. Robert Redford and the Sundance company called, and they were setting their whole film studios up on software, and they wanted, our help.
Did he call him himself?
No, he had somebody call, but he used his name, so it was like,
Right.
in the switchboard, there's not a lot of action going, so it's like, oh boy, look who called today.
So what other jobs after being a switchboard operator, what other things have you done at Microsoft?
After that, I went into applications marketing and worked as an admin in there, and that's 88 to 90. And then I went to work for the MSDN group.
What did you do for them?
I was their originally project coordinator, and this is when there was only 3 people in the whole division, and we were setting up all the purchase orders and the whole logistical move to make CDs.
So I imagine the MSDN CD was probably one of the first usages of CD-ROMs back then?
Sony and one small company in California were the only people that made CDs at all in the United States. So I took a trip to Terre Haute, Indiana to check out the Sony process. It was really
New
interesting.
technology.
Right. It was very new technology. They were just at that time even doing 3.5-inch discs. They had moved from the 5 1/4 to 3.5, so that was just being set up also. And at that time, they just came out with Nirvana CD and were doing the Thriller one, but they wouldn't let us see the cover of it. We were sneaking around there trying to find it.
So Nirvana and the MSDN CD launching at the same time.
Right. Well, it was a couple of years later for the MSDN after they got the development going. The group got way bigger.
So tell me a little bit about what you do outside of work.
I have a home at the ocean, and I have a couple of grandkids that I take with me quite a bit. And let's see, I've been married for 33 years, which is actually longer than most people are old here at Microsoft.
So being here so long, do your grandkids or have your grandkids asked you about what it's like to work at Microsoft?
No, my grandchildren are a little too young. They're one just turned 6, and the other one is just 9 months. But the 6-year-old plays with software all the time. He likes playing on the computer.
Lynn, thanks for joining me today. It's been great.
It's been a lot of fun. I hope I said something interesting.
You did, thanks.
Oh, you're welcome. How bad? Oh, God. It is! Oh, no. Robert. Maybe I have to say, and then Robert and I went to Boston once, and he said to me, "We're in the wrong part of town, Lynn." And I said, "Robert, you walk a lot faster than me. You need to slow down." Remember that we were...
Thanks for joining us for this episode of the .NET Show.
And stay tuned for the next episode where we'll further explore more .NET technologies.
And until then, we'll see you on the web.